Hello and welcome to today's video. We're still looking at functions. Today we're going to look at how functions can call themselves to carry out tasks that can be broken into smaller subtasks. This is called recursion. Let's look at some examples to see how that is implemented. Open your IDEs and let's dive right in. The first example we shall look at is dealing with factorials. The factorial of 4, for example, will be 4 times 3 times 2 times 1. So it's the result of all the numbers equal to and less than 4, all the positive integers equal to and less than 4. So that means the lowest we have is 1. But this can also be written as 4 times the factorial of 3, and the factorial of 3 can equally also be written as 3 times the factorial of 2. The factorial of 2 can also be written as 2 times the factorial of 1, and the factorial of 1 is 1. The very last number we can have here is 1. So when we're creating a recursion, we need two things. We need a base case and a recursive case. The base case is this one right here. In this case, it's the lowest, the last thing we could possibly have. And the recursive case is what will cause this to happen, to call the function that creates a factorial and make it create a factorial for all of these and carry out these steps. Let's look at the implementation. So we're defining a function. Let's call it factorial. Open the parentheses, and it takes in an integer n. For this function, as long as we have a number n that is equal to 1, we shall return that 1. But otherwise, as we saw before, this is our base case. This right here, this condition, the condition that is met and stops the function, that's the base case. If that condition is not met, what we shall do is that we return the value of this n times the value of this factorial function, but this time the n minus 1. Let's run the code and see what we get. So we call the function factorial, open brackets, we take in 4 as we were using before. When you run it, you see that there is nothing being output because we were using the return keyword. Remember, the return keyword does not print anything. So if we want to see results on the screen, we use print. And now when we run it, we shall see that the factorial of 4 is 24. Let's go back to the broken down example we had looked at before. So we had 4 factorial being equal to 4 times 3 times 2 times 1. And we saw that we could break that down further into having 4 times the factorial of 3. We could break that down as well into having 3 times the factorial of 2. We went further and looked at having 2 times the factorial of 1, and the very lowest number we could have is 1. So that means this one is where we stop. So what our code is doing is that it starts from here. We have a number 1. Is this n1? No, it's not. The n is 4. So then we get 4 over here times the factorial of 3, and then we get the next number 3 times the factorial of 2, 2 times the factorial of 1, until we reach this one and we stop. Then we print the result. Let's look at another example and see how we can implement recursion. The other example we're going to look at is that imagine you're at a birthday party and we are counting down now. It's time to cut the cake. So we count from a certain chosen number and we go down and down and down. Let's create a function for that and we shall call it countdown. So it takes in a number n as well for the number of times that we want to count down. In this case, as long as this n is less than or equal to 0, we shall print happy birthday. So this is the point where we shout happy birthday at. Otherwise, we shall print that number and then we call the function to do the same thing again. So we call the function countdown, and this time we're using n minus 1. Let's call this function and see how it works. Let's count down from 5, for example. When we run it, we shall see that we start from 5, 4, 3, 2, 1, and then we shout happy birthday. Let's break the code down a little further and see and try and understand. So this condition up here is the base case. Think of it as a flight of stairs, and the very bottom one is the base case. It's where you stop going down. This over here, when we call the function, this is the recursive case. So for every recursion that you'd want to implement, you need these two cases in order for it to be successful. But sometimes when you put in too many values here, for example, if I decided to put 1005, when I run that, it goes on and on and on and on and on. But will not be able to complete because we get something called a recursion error. A recursion error happens when the maximum recursion depth is exceeded. That means there's too many arguments we're putting in. So there should be a limit to your arguments in order to prevent this error. I think the maximum number is listed here, 955. 995. So when we run that, we can check and say, let's scroll to the bottom, that it actually reaches. That means we are able to complete and reach the bottom stair. This is recursion. This is how it works. Go ahead and practice. Check out the practice questions, look through the notes to get more understanding, and I will catch you in another video.